Do. Live? Is it live? Think I'm live? Yeah, I'm live. Okay. What's up, guys? Right now, so I'm actually on my bed right now, and I'm pretty tired. So I didn't connect the microphone to it. So yeah, I didn't connect my. So I have like a separate microphone to record. So yeah, I'm actually on my bed right now. I'm about to go to bed, but I'm gonna upsolve one more problem before I go to bed. So I did upsolve the C problem of AtCoder Beginner 190, bowls and dishes. Basically, their editorial, so I already did this off camera. Basically, their editorial was just to brute force all the dishes and then just check which one has the most conditions that were set. So that was what C was. I'll actually go over the edit explanation in another video, but for now, I'm gonna upsolve the problem D, which is how many arithmetic progressions consisting of integers with a common difference of 1 have a sum of n. So I actually had no idea how to do this. Like I don't even know where to start. So right. So I'm just gonna go to the editorial because, I mean, what are you gonna do? Keep loop from negative infinity to infinity and just sum up all the values to see if you can get to n. Right? I have no idea how to do this. So I'm actually just gonna go to the editorial. Right now I'm not 100% sure. Yeah, I'm gonna try live streaming every day, but I'm not 100% sure how I'm gonna do that. Cause I don't really have like a set schedule to live stream, so I might put a poll in the community tab to see if I should live stream what's the best time for you guys. Cause I also have school right now, Zoom University right now. Yeah, let's go to the editorial. So problem is that how many arithmetic progressions of integers with a common difference of 1 have a sum of n. I actually don't understand why this is the case. So if you sum from a to b, it's a plus b times b minus a plus 1 over 2. I don't know why this is the case. I think because sum of 1 to n is a plus. Sum of 1 to b is b times b plus 1 over 2, right? So I don't know what that means. We're just going to be adding b minus 1 to a plus 1, a to each element. I don't know what that means. Yeah, I don't know what that means. If anyone's in the live stream, it's fine. It's okay. Oh, there's people watching. Wow, that's crazy. Let's see. If you want to comment down in the participation. The comments and it pops. Yeah, but we're trying to do this problem. Anyone watching right now, we're trying to do this problem. How many arithmetic progressions consisting of integers with a common difference of 1 have a sum of n? So here, sum of sequence of a to b is a plus 1 times b minus a plus 1 over 2. The problem is equivalent to finding number of integer solutions of a plus b times b minus a plus 1 is equal to 2n. Sure, if this equation is correct, right, then you set this equation to equal n, and then you find this. Here, a plus b, b minus a plus 1 are both divisors of 2n because they're both integers. So we could enumerate by decomposing into two positive integers like 2n and x times y and solve this. So we could enumerate a plus b is equal to x, b minus a plus 1 is equal to y. So we can find the number of integer solutions. The solution is x minus y plus 1 over 2, b is equal to x plus y minus 1 over 2. If the parity is x and y differ, otherwise there are no integer solutions. Therefore, the answer is the number of ways to decompose 2n into two different parities. If the parities of x and y differ, then there are no solutions. Otherwise, there are no solutions. Okay, so if they don't differ, there are no solutions. Answers in two ways to decompose it. Since the divisors of 2n can be enumerated in a time complexity of root n, the problem can be resolved in root n. Since 2n has at least one on the prime factor, 2 is a divisor. Therefore, the solution of the answer is the number of divisors of m times 2, where m is equal to n repeatedly divided until it's divisible by 2. Huh. I don't know what that means. Let's try to implement it ourselves first. I'm going to close all my tabs. So many tabs. There's only one. I know that it's not that many views right now. It's okay though. It's okay. Just trying to basically solve some problems. If you guys are new here, I'm just trying to solve some problems. So yeah, let's see. Ax minus y plus 1 over 2. I don't understand. Enumerate? Do we just enumerate through them and then just if x plus y, a plus b is equal to x. So just enumerate through this? Just enumerate over... So enumerate over x and enumerate over y over root n. Since 2n has at least two ones in the prime, not both has 2 in the divisor. Therefore, the answer is m times 2, where m is equal to n divisible by 2. So it's... Huh? I don't understand. Since 2n has at least 2 as its prime factor, but not both, x and y has 2 as its divisor. Therefore, the answer is number of divisors of m times 2, where m is equal to n divided by 2 repeatedly until it's indivisible by 2. I don't understand. If the parities x and y differ, otherwise there is no such integer solution. Therefore, the answer is the number of ways to decompose 2n into two integers of different parities. Since the divisors of 2n can be enumerated, since 2n has at least 2 as a primary, but not both, therefore the answer is number 2. Let's actually look at other people's solutions. I feel like it's not this complicated, even though it's not, because their solution is kind of saying like they must have different parities, right? No, otherwise they're... So if they have the same parity, it's not... I don't know. How do you get from here to here? Right, x minus y plus 1 over 2. X plus y minus 1 over 2. So they are different parities? How do you know? Let's say x is 5, y is 3. Then you're going to get 5 minus 3, which is 2 plus 1, which is 3, 3 over 2. 5 plus 2, no. Okay, let's say it was... Oh, so they have to be different. Wait, no. Is it the same? Okay, let's say it was x is 5, y is 2. So 5 minus 2 is 3, 3 plus 1 is 4, 4 over 2 is 2. Okay, that's right. 5 plus 2 is 7, minus 1 is 6, over 2 is 3. Okay, so they have to be different parities. Okay, so they have to be different. One is odd, one is even. That's what that means. What's up? How you doing? Ujik. How you doing? Right now, I'm just trying to figure out problem D of AtCoder Beginner 190. It's basically the question is asking how many different numbers, how many different arithmetic progressions are there with a common difference of 1 have a sum of n. This is a combinatorics problem. So, yeah. They're saying this is the thing that you have to do, but I don't understand. Okay, so now the A has different parities, right? A and B have different parities. Their numbers, different ways to compose into two different parities. Okay. Since the divisors of 2n can be enumerated in time complexity of root n, the problem can be solved with a total of root n. Since 2n has at least 2 as its prime factor, either but not both, x and y has 2 as its divisor, therefore the answer is number of m's times 2. Number of divisors of m, where m is equal to n repeatedly divided by 2 until it's indivisible by 2. I don't understand. Why do you do the answer minus minus? What is this part for? Okay, let's look at other people's solutions. AC, let's look at D. Let's look at D. Let's look at this guy's solutions. Oh, wow. If it's 1, you print 2. Otherwise, you do I times I plus 1 or less than or equal to 2n. Okay, so he's looping from 1 to, so he's using the summation formula, right? And he's looping from 1 up to the summation formula of 1 to n. What is y? Y is 2n minus, so the final value could probably minus I times I minus 1. If y mod by 2 times I is equal to 0, we add by. You check if y is not equal to 0. If it's not equal to 0, plus 2. Otherwise, you plus 1. I don't understand their solution either. Let's look at other ones. We'll keep looking until we find something. I times I over 2. Multiply by 2, that makes sense. I times I over 2. I times I less than n. Okay. We mod by I. If it's divisible by it, right? If it's equal to 0. What? If it's equal to 0, if it's divisible by I, you divide n by I minus I and by 1. What? This is okay, so this is checking if it's odd. Right? Ending by 1 checks if it's odd. But n over I minus I. What does that even mean? That's n minus I squared over I. Check if that's odd. I don't know where they got that formula from. Do you remember me? QC. I don't. Wait, who are you? QC? Who's Q underscore C? I don't know who you are, sorry. You gotta jog my memory. Okay, here, let's look at this, guys. Keep dividing by 2, okay? I times I is less than or equal to n, okay? Let's just go to square root of n. If I times I equal to n, okay, that's weird. Answer plus plus. Also, if I minus u, right, plus 2. Huh? Number of divisors is really difficult. Let's look at this guy. Loop to 2n, okay. If 2n is divisible by I, if it's not divisible by I, wait, what? And 2n minus 2n over I minus I is odd. I don't understand. I don't understand at all. I don't understand. Why is this the case? Do you remember? Yeah, I don't. How you doing, Kunal? Kunal? I don't understand this problem. For D. Problem D. An AtCoder beginner 190. Because if you're going 2n, like... Okay, I got this part. Actually, first of all, this equation doesn't really make much sense to me. But let's say it does. So what they're doing is they're setting equal to n. And then they multiply by 2 on both sides, so they get this. So I understand that. They just let the values of a plus b equal x, y. Okay, they solve for a and b. If the parodies are different, yeah. The answer is a number of ways to decompose 2n to do two different integers of different parodies. Okay, I understand that. Since the divisors of 2n can be enumerated in time complexity of root n, problem can be solved in a total of root n times. Since 2n has at least two 2's as its prime factor, we either not both. X and y has 2 as its divisor. The answer is number of divisors of m times 2. M is equal to 2 divided by 2. So how do you find the number of divisors? So is that what this code is doing? I'm guessing that's what it's doing. Is it finding the number of divisors of 2m, of m? I don't know. I don't know. This question doesn't make sense, but let's say it does. So you see you learning. That's the law of contraction. What? Okay, William Tubbs. Okay, sure. Okay. At least we're learning. Okay, so I kind of understand this problem. I sort of understand. So let's not copy their solution just yet. Let's actually just try to base on this. If we still don't understand, then let's copy it though. Okay, so read an n. If you guys are wondering what the question is, it's staircase sequences. AtCoder D. How many arithmetic progressions of integers for the common difference of 1? Yeah. Let's see. Okay, so I'm actually going to try attempt this problem myself. So for now, let's just read an n. And let's call solved. Okay. So I put solved as in... I have n as a global variable, so I could use it in solved. Excuse me. Okay, so loop from I to I times I less than or equal to 2n. And the reason why we're doing I times I, this is going to go to square root of 2n, I think. Because they said we could do numerator root n. Since 2n has at least 2 as a prime number, but not both, x and y has 2 as its divisors. The answer is the number of divisors of m times 2, where m is n divided by 2 repeatedly until it's not divisible by 2. So, okay, so let's call m. M is going to equal to... Okay, so while n is divided by 2 equals 0, we're going to keep dividing it by 2. And it's going to keep dividing it 2. Okay, so that does this part, that's technically m. So now we're just going to find number of divisors of m. M, which is... Oh, actually, it should be this. n because that's so our m is so I basically just kept dividing n by 2, and that's going to make our n equal to the m. Number of divisors m divided times 2. So now we just need to find the number of divisors of n. So if I just do if n is mod by 2 mod by I is equal to 0, divisors plus plus. Can I just do that? And here I just print out 2 times divisors. I don't even know. I don't know if this is right or not. But let's try. Law of contradiction. Sure, law of contradiction. Let's see, what did I get? I got 2 wrong answers, and then what else did I get? 4 wrong answers. 33 wrong answers. It's pretty slow. Now that I realize it. So lazy. I'm pretty lazy right now. Super duper lazy. So lazy. Very lazy. What time is it, guys, for you guys? Law of contradiction. Yep, law of contradiction. I have no clue. When should I stop live streaming? Oh, it's been 21 minutes. I'm probably going to stop in another 30 minutes until I solve this problem. Maybe I'll try E after this. So C, D, E. Yeah. I'll try E after this. How many problems are there? There's F, shift and inversions. I don't know. Problem is difficult. Do I use Viscade for Visual Studio? What is that? What is Viscade? What's Viscade? I don't know what that is. Extension that you do during programming part. Huh? What does this do? What does this look like?
Welcome to.
Oh, what the? That was too loud. That was too loud.
We've got 3 projects here.
Huh?
In CPP lib, this is where you want to put your live.
What does this extension do?
CPP, you can see that.
I have no idea. Maybe, maybe not. I don't know. I don't know if I'll use that. CP parser. No clue. I kind of like typing things out, but maybe. Maybe in the future I'll look through it. Oh yeah, what was my submission? Ah, fuck, that's E. My submission. So I know I got. Did I get all of them wrong? I got 1 AC power. I got TLE samples. Second one I got AC. Okay. So this is not how you calculate the number of divisors. Pretty sure it is, right? Oh, what the? Total number of divisors we give a number. This sounds terrible. This sounds terrible. Number of divisors for a given number. Use a sieve for prime calc. Okay, so I have the sieve. Traverse through all prime numbers. If it's, wait. P1 plus P, what? If it equals 0, why does you divide plus plus? Oh boy. Is that what they were doing here? I don't understand. How is this calculating a number of divisors? Let's try using this way. Loop through all prime numbers. Okay, so I could generate a prime numbers with the sieve function. So I have a sieve function here. So I could use this. So I'm gonna generate sieve of up to n. Okay, I generate the sieve function. Now, if it's prime, what did they say? If it's prime, loop through from 2 to n plus plus. Why? Why? Okay, traverse through all prime numbers. Why? Okay, I could do that, but I don't know. Divisors equal 1. Traverse through all prime numbers. So I'm gonna actually traverse. I'll do this. If I is prime, I have a primes array. So if I is prime, what do they do? Count 0. If n is divisible by p. Wait, what's p? Oh, that's I. What did they say? While n is divisible by p? Okay. Fine. Divided by p by I, count plus plus. Divisors times equals. Okay, this is just more formulas. Oh, it equals divisors times count plus 1. Okay, I don't even know if this works. So right now at this point, I don't even know what this is doing. Okay, but let's say this works. Assuming this works. If this is not working, I'll look at other people's code. And I already did look at other people's code. Let's just continue looking at other people's code. Maybe we'll get something. Is it working? No, 2 TLE. You know, if we get 1 TLE, the code should just stop. Okay, let's actually look at RE. Okay, RE is even worse. I think that's like overload or something. Okay, let's look at results of submissions. D language, C++, status AC, search. Okay, here. Okay, I understand what they're doing here. Okay, loop through square root of s plus 1 if it's divisible by it. Okay, if it's divisible by it, and s times s, I times I equal to s. So if the value is the square root of s, add by 2. Why? That doesn't make sense. Otherwise, add by 4. Man, these codes don't make sense. It's difficult. What is this? Oh, never mind. Okay, times by 2, loop through I. Okay. N over I minus I plus 1. What does that mean? Okay, so this is like, okay, so this is looping through 1 to square root of 2n. And I understand why. Because we have to do this to 2n. If it's divisible by I, they divide it by I, subtract by I, plus 1. Which doesn't make sense. Divided by I plus by minus. Oh, wait. Wait. So, like, let's say when you minus by I think it's getting the next number in the progression. Right? I think. No, wait, no. Are they trying to find the number of divisors? I don't even know at this point. Why in editorial line 2 they do 2 plus? You done with question 1? Question 1. In the last stream, I solved question 1. So I've solved A, B, and C. I'm trying to figure this problem out. Why in the editorial are they doing n mod by I equals 0 plus 2? That's the thing that I don't understand. How does this find the number of divisors? Okay, wait, okay. Let's think. This is going through the square root of it, right? We're going to go through every number. If it's divisible by it, we add by 2 for some reason. Why do we add by 2? I don't know. I don't understand. Why do we add by 2? So is this finding the number of divisors? Because shouldn't it be plus 1? I don't know. Sum NF for I. Python doesn't make much sense either. Yeah, Python doesn't make any sense for me. I don't know. I don't know what the problem is. William Tubes. Maybe it's because I don't know. Let's look at other people's code. Let's continue doing that. Okay. Staircase. So let's look at D. Okay, yeah, I don't understand this. Why do we add by 2? That's what I don't understand. Why aren't we adding by 1? Let's look at this. Okay, times by 2, let's go up to square root of n. We're going to divide it by I. Then we subtract by I plus 1. If it's divisible by 2, if it's even, we add 1. then x minus I minus I plus 1. Read and understand special overflow, mem set, do something instead of nothing, stay organized, write stuff down. Oh man. Man. These people don't really care. Wait. Is this the same? I just clicked on the same code. Heck. Why are we... Who writes this? Who puts the 0 before the... Oh my god. Alright, this person just wants to make the reader angry. That's what this person is trying to do. Who puts the 0 in front? Who puts the number beforehand, before the equal sign? Like, that's just... Oh my god. Okay, let's just keep going. Oh, I just clicked on the same code. Let's look at this. N minus 1 times I minus 1 over 2. Oh, wait, I think I understand this better. I times I minus 1 over 2, that's the summation of I minus 1, I think. Right? Right? I minus 1. Because n times n plus 1 over 2 is the summation of n. So, if... a plus 1 up to a plus k is equal to n, which implies that a is equal to n minus k times k plus 1 over 2. Oh. Which means that it must be divisible by k plus 1 if a is an integer. Okay, this makes more sense. So let's find the values 1, 2 to I times I over 2. So this goes to square root of 2n. N minus I times I minus 1 over 2. Yes. If this is divisible by k plus 1, what is k plus 1? K plus 1 is I. Oh, if it's divisible by I. Oh. Okay, I think this makes more sense. Okay, yeah. If it's divisible by I, then and value is greater than or equal to 0, then you could say count plus plus. Summation of a to a plus k. That's what it equals to. Oh. I times I plus 1 over 2. A plus 1, a plus k. Therefore must be divisible by I times I. This is genius. I think this is a better way. I understand this more. So basically what they're doing is that... Okay, so... What they're doing is that they're saying is that if we're going to loop from... So we want the number of arithmetic progressions that sum is equal to n, right? So if we let any if we loop from 1 to square root of 2n, so if we set the value equal to n, right, and we solve the equation, the value is going to get to 2n, right? So what they're doing is now they're going to loop from 1 to square root of 2n. So because we know that a summation of 1 to n is I times I plus 1 over 2, right? As n times n plus 1 over 2. So here what they're saying is that A is any number, so what we're doing is sum. Is if we're summing from A to A plus K, it's going to be n minus, which is equal to n, right? If this value is equal to n, this must imply that A is equal to n minus k plus 1 over 2. So because we're going to k, this is summation of n minus summation 1 to k. So they're moving this, so they're solving this sum of 1 up to k, and they're saying that's the equation of k times k plus 1 over 2. And because we know this equation equals to n, right? That means that n minus k plus k times k plus 1 over 2 is our value of a, and this must be divisible by k plus 1. Yeah, it must be divisible by k plus 1. Because a has to be an integer, yeah. So if they check if it's divisible by a, okay, so let's actually rewrite this. So let's actually rewrite this. So I don't need this anymore. So we have a count is equal to 0. What they're doing is they're going to loop from, actually I'll use a because that's how they're doing it. So this is going to loop from 1 to square root of 2n. Okay. Now what they're doing is that they're going to, this implies that if we're summing from a to k, so we're summing a plus 1 up to a plus 1, oh, what was my battery's low? A plus k, right? So this 1 to k is k times k plus 1 over 2. So hold up, I need to charge my laptop. So this has to equal to n, right? Because that's what the problem statement is saying. So this means that the left side, I could actually just write it down as summation of, so this left side, I could simplify this down to like a plus yada yada yada, a bunch of a's. So I can move this 1 and 2, 3 up to k, right? So this is like plus 1 plus 2k, right? I could just shift this 1 to the right. Basically move the 1 around, right? So that's the summation of 1 to k, right? If you get rid of the parentheses and just shift things around. So then this means that a plus a bunch of a's, right? So 1 to k plus is, the summation 1 to k is k times k plus 1 over 2. Right? From the formula. So then what they're saying is that a is going to equal to n minus, well, is that true? Oh, yeah. So a bunch of a's, right, added is going to equal to n minus k times k plus 1. Right? But it's not just 1a though. So this is divisible by a. So what they're saying is this answer has to be divisible by a. Yeah. That's what they're saying. So this is what our value is going to equal to n minus k times k plus 1 over 2. which RK is just 8, right? I think. Yeah, 8 times 8 plus 1. Yeah, that's what I'm doing. Which means it has to be divisible by yada, 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 yada. Oh, this is confusing me. Yeah. N minus 8 times 8 plus 1 over. Oh, wait. What? Why is it I minus 1? Huh? Shouldn't it be plus 1? Yeah, there's no advantage writing the 0 first. Uh... 0 equal to 4 gives an error. Present 0 equal to 4. If n is divisible by I, then it would be divisible by n over I. Because 1 over n over I is equal to n. Therefore, answer. Wait, why would it plus 2? That doesn't make sense. If it's divisible by I, and you divide it by I, you get n. Why would you add 2? Wait, what's going on? I don't know. But yeah, wait, shouldn't this be I times I plus 1 over 2? Why is it I minus 1 over 2? K minus 1. Oh, wait, summation of 1 to K minus 1 of I minus 1. Oh, so this is summing up to I minus 1. So n, so for some reason they don't want to do up to K plus 1, so they want to do a K minus 1. I have no idea. So yeah, let's just do this. If it's greater than or equal to 0 and is divisible by I, then we'll do it. Then answer plus plus. At the end, we just see out count. I'm pretty sure it should be I plus 1 though. A times A plus 1. But yeah, we're gonna cement now. But let's look at other people's code. I'm just kind of curious because it actually doesn't make any sense what some other people are doing. Why add by 2? Going up to the square root, why add by 2? Okay, I got wrong answer. What's the problem? I did val mod by val. It should be A. So this solution makes more sense to me than the other one. Why am I getting wrong answer? Huh? I don't get it. Oh yeah, wrong answer. I don't know. Try submission 19857. What's this? What is this? In a way, we have to calculate the factors of 2n. Sure, yeah. But what? Oh, okay. I guess so, but okay. What submission number did you want me to do? No. I don't know. I don't know what. What did they say? Submission this? How do you search by submission number? Whoops. Oh no. Okay, so you're saying we have to add by 2 because we have to check the factors of 2. Type in URL. Huh? I don't know. I don't know. But if that's the case, why do they minus 1 for this? Because if the square root is equal? I don't know. Okay, we could do that. Let's just copy their code at this point. I'm pretty tired now. Super duper tired. I also have class in the morning. So we have this. You're saying if I n mod by I is equal to 0, n is plus equal to 2. Just make it I. Make it more consistent. What was it? While n is mod by 2 is equal to 0, right? Just keep dividing it by 2, right? To make it odd or something. So they're saying. Then they said C out 2 times ant. I think this part was for double counting. This part. But if we're going I times I don't think it would matter. Oh no. It does. Apparently it does. Apparently it does. Okay. Why does it matter? Okay, so for double, okay, I guess we're not doing this. This is less than or equal to? Yeah, less than or equal to. Okay, so they don't want to do square root of I. They want to do this way. Okay. That's such a weird way to do it. Let's call it like I don't know, end. I don't know. What did I just paste? Okay. And they said if n times n is equal to n, we subtract 1. I don't get it. I don't get why that matters. For what? Man, I literally just took the same code though. N times n is equal to. Oh, do they mean 2n? No, that's what they did here. Wait a minute. Something's not right. I times I is equal to plus 2. Square root. That's right. But that's right though. Square root of 2n. It is because for the factor will be calculated twice, so we subtract 1 if it's a perfect square. Michael Lin. Loading, please wait. Alright, dude, you're spamming me in the chat. So if it's a perfect square, we wait? I don't know. Perfect square, we wait. Something's strange then. I don't know what's wrong. Okay, answer 0. Square root is 2 times n. Square root of 2 times n, right? Oh, square root of n. That's weird. Okay. Why do we divide by 2 every time? Number of ways to decompose it into 2 different parodies. The divisor of 2n can be numeric complexity solved. Since 2n has at least 2 as its prime factor, either but not both, x and y has 2 as its divisor. Therefore, the number is number which repeatedly divided by 2's. I don't know. I don't know why this is the case. I have no clue. Yeah, it's a seed, but I don't know why. Why do you have to keep dividing by 2? Okay, I think it makes sense about n times n. But retracted. I don't know. Let's look at other submissions. Let's keep looking at other submissions. Okay, let's look at this. See, I don't understand what they're doing here, though. Okay, a 129 submission. Oh, wait. Okay, I'll look at your submission. Try submission this. Find the square root of n, repeat 2. If it's visible by it, what are you doing here? Divided by I. If you add by a mod by 2 is equal to 1. What? What does that mean? That makes no sense. Add by a mod by 2 equal to 1. 12 plus 12. Oh, these are a lot of negative 1 to 5 plus 5 times 5 minus 2 times 1. Wow, he really listed out all these problems. Huh. That's crazy. So if it's odd, yeah, that's actually kind of crazy. Should we end the live stream now? It is 1:30 for me. Yeah, it's about an hour. I'm gonna end the live stream. Hope you guys enjoyed this live stream. Rate, comment, subscribe. I'll check you guys later. I'm really tired. Peace.